how much VRAM a particular ollama model needs. Let me check if this online tool can make a good estimation. I will set my GPU here first. I have Tesla P100s, by the way, it's the first data center GPU produced by NVIDIA. GPU set, now you need here an LLM model name as it's used on Hugging Face website. Hugging Face is like GitHub for machine learning models. So to get the proper name, I'm going to check for a Hugging Face link on the model page in ollama library. And here on the Hugging Face page, I'm looking for a 32B instruct model, because instruct models are the models used for chat interfaces, and this is my use case. So here is the Hugging Face page of the exact model I want to estimate. Let me copy the model name now and put it in the VRAM calculator. Now, as you can see, the results here are a bit involved. First of all, I'm only interested in the inference part because I will only use the model in the chat interface. I will not fine-tune or train it. Then these individual color bars are for different data types used for neural net weights. Weights represent how strong or weak are connections between artificial neurons. Obviously, a 32-bit float data type can express a wider range of values for weights than an 8-bit integer. But billions of 32-bit floats add up to a significantly bigger size of a model than if it would be built up of 8-bit integers. If we look at the ollama library page again, there is the quantization parameter in the model description. Quantization is exactly the process when those weights are cut to smaller data types, kind of what happens when a WAV file is encoded to an MP3. So where ollama page says Q4, it would be int4 in our VRAM calculator. If you want to get a model without quantization, click on text link on the model page in ollama library and look for FP16. As you can see, a 32 billion parameters model is massive without compression, 66 gigabytes. It will not fit in my GPU card's memory. I can still run it on my server using CPU and RAM because my home lab server has a lot of RAM, but this probably won't work for a typical laptop. And then it's not really obvious that a full model always has an edge over a compressed one. At least it's not easy to spot the difference. I personally try to use models that comfortably fit my available resources. Not only they load faster, they also generate answers quicker. Back to the calculator. Qwen 2.5 coder model with 32 billion parameters and 4-bit quantization should fit exactly my two NVIDIA P100 16GB GPUs. That's what the page says. But let's prove if that's true. It looks like the calculator can answer the question correctly.